Okay, here we go, back in business. So last week we looked at exponentials in the form of y equals a times b to the x, okay? And none of those were shifted, and all we did was try to figure out what that value of a and b were, okay? So this is what we did last week with no shifts. This is what we're going to do this week with shifts. So the only difference is that h and k, okay? Now, it's just going to tell you how your parent graph shifts. So, Zeth, put that away. H is going to shift left and right. So if it says something like x minus 3, it's actually going to shift right 3 because H lies. It does not tell the truth. It's a fibber, okay? But if it said x plus 3, that shifts left. And then K is going to shift the graph up or down, and K tells the truth. So H lies, K tells the truth. So if it says plus 5 on the end, then this is going to shift up 5. But if it says down 5 or minus 5 at the end, it will truly shift down 5. Okay, so it says, are the graphs growth or decay? How are they reflected? And how are they shifted? What was the last one? Minus 5 would be down 5. Okay, so are the graphs growth or decay? What you are going to be looking for in the equation is this number right here that has the exponent on it. The base of the exponent is what you are going to be looking at. So, if the base of the exponent is greater than 1, it's growth. But if it's less than 1, it's decay. Which makes sense because if we take 2 and we raise it to a power, we're going to get larger. 2 times 2 times 2 times 2 times 2 is going to get larger. But if you multiply something that is smaller than 1, like a half, times itself over and over and over, a half times a half is a fourth, times a half is an eighth, times a half is a 16th. Bless you. It gets smaller and smaller and smaller. Okay? So, we are going to look at the base of the exponent to determine if it's growth or decay. What are we going to look for to determine if it's reflected or not? What's going to tell us if it's reflected or not? Crickets. What's going to tell us if it's reflected or not? Number 1, we want to first say if it's growth or decay. What would you guys say? Growth. Because the 3 is larger than 1. Notice I'm not worried about the sign. I'm just looking at the actual number itself. Because that negative out front could really be a negative 1 times 3 to the x plus 2. Okay, so is it reflected or not reflected? Reflected, yes or no? Yes, why? Has the negative out front. Good. Okay, and now the last thing we have to determine is it shifted? Okay, now the h is always going to be in the exponent and the k is always going to be off at the end, a bigger number. Okay, so if we look at the h, it says plus 2, and we know that h shifts left and right, but h lies. So which direction are we going to shift? Left 2, right? And k tells the truth, so the plus 4 is going to shift up 4. So we're going to go left 2, up 4. And Mitch, if you want to go ahead and put that book away for me while we're doing this, I'd appreciate that greatly. Rolling the eyes helps too, you know. Multitasking. Thank you. Okay. Number 2. Growth or decay? Decay, why? That's right. The 1/3 is less than 1. I don't care about the negative out front. I'm just worried about the actual numerical value of that base. Reflected or not? Yes. Because of the? Yes. The negative. Do we shift left and right? No. There's nothing added or subtracted to x. Okay? But the -3 tells us that we shift where? How do we shift that? Down 3, right? Okay, I want you to try 3 and 4. Check your answers with mine. See how you did. Any questions? So we've got a growth, we've got a decay because bigger than 1, smaller than 1. Not reflected on either one of them because neither one are negative. This one, number 3, does not shift up or down because there's nothing added off or subtracted off of the end. And then number 4 is shifting both right and up. Any questions at all? Okay. Let's look at this graphically now. It says compare the following graphs, describe the shifts from A to B. Now, on Friday, we shifted everything from a parent graph. Now today, you really need to pay attention to graph A compared to graph B because all of graph A is not going to be a parent graph necessarily. So you want to pay attention to the point on the y-axis, the y-intercept, and figure out where it starts and where it ends. How does it shift? Okay? So if we look at number 5 here, our y-intercept starts at 1, and how does it shift? Where does it shift to? Started at 1 and it shifted to -3. So that would be a shift down 4 units, right? Because if you go from +1 to -3, that's actually 4 units. Okay, now if you look at number 6, graph A this time does not start at 1, it starts at 3. So be careful there. We're starting at 3, and we shift to -2. How are you shifting? Down 5. And then number 7, I skipped 6? I just did. Yeah. From 3 to -2? Down 5? Number 7 has a y-intercept of 1, and then it has a y-intercept in graph B of -1. Did that shift down too? No. What happened in this one? It reflected. It flipped over the x-axis, right? So it reflected. And it did not shift it after that. Okay. We can extend this to linear functions as well. So if you look at number 8 has a y-intercept of 2 in graph A. And in graph B, it has a y-intercept of -3. So it went from 2 to -3, which means it shifted down 5. Yes? Okay, now number 9 is different from 8. 8 is the exact same graph, only shifted down. But in number 9, the line changes what? What about it changes? The slope changes, right? Okay, they both go through the origin, so the y-intercept is the same. But talk to me about the slope in number 1. What is the slope in graph A? What's the slope in this graph? 1, right? Rise over run. So just up 1 over 1, so a slope of 1. But what's the slope in B? 1/4, right? Rise 1 and run 4. So the slope changes from 1 to 1/4. So it's not necessarily a shift like up or down, left or right, but it's changing steepness. Okay, number 10. Number 10 is just dealing with equations, and the first equation says y equals 2 to the power of x plus 1, and equation B says 2 to the power of x plus 3. So this graph has a y-intercept of what? 0, 1, because it's shifted up 1. That's what this tells you. And this has a y-intercept of 0, 3. How does it shift from graph A to graph B? Up 2, yes? And in 11, we have a y-intercept of -4 and a y-intercept of -1. Now notice I used b for y-intercept there just because y equals mx plus b. It's a linear function there, so we usually say b, but if you wanted to write 0, 4, -4 and 0, -1, that's fine too. But how did we shift this? We're actually going up, right? Because if we started at -4 and we shifted to -1, our graph actually moves up because it's less negative. So we're going to shift up 3. Good. Number 12. This one, we don't have a change in y-intercept because they both have +0 on here. So they both have a y-intercept of 0. But what is changing? The shift left and right? So this one shifts right 3. And this one shifts right 5. So if we start at 3 and we shift to 5, how much have we shifted? 2 to the right, because we're getting bigger. From 3 to 5, we get bigger, so we shift right 2. Does that make sense? Okay, number 13, back to linear functions. If you notice, what they have in common is the y-intercept, but what is different is their slope. So we change slope from -2 to -4. So did that become steeper or less steep? What do you guys think? Steeper or less steep? Steeper, right? The bigger the number, the steeper it is. Good. Okay, number 14. Back to exponentials. We have a +0, +0, so they both have a y-intercept of 0. This one shifts right 2, and this one shifts left 4. Ooh, be careful there. So we're starting at 2, and we're going to -4. So we are actually shifting which direction? Left? How many? 6. This one is +2, essentially. And this one, because we're going left, is -4. So how do we go from +2 to -4? We have to shift left 6. Okay. We've got, what, 2 more examples here? It says if the equation y equals 1/2 to the power of x minus 3 is shifted down 2, what is the new equation? Okay. The down 2 goes with the k, that's off at the end, so we would have to